Hi there, my name is Luis Gonzalez. I'm one of the ElkBros, definitely, undoubtedly, the leader of the Venezuelan mafia, regardless of what anybody else would say. Um, Coming to you today with a topic that a lot of people has asked about. And just want to make clear that by no means I'm an expert or a professor or I did not come up with these theories or factors and concepts that we're going to be talking about today. I'm just here simply sharing the process I went through in order to build an arrow that I thought it suited my needs. And again, the way I see it, arrows could be built in such ways that it depends on what you're going to be hunting. So same with a rifle, depending on what size animal you're going to be hunting, you're going to want to increase your caliper or have a lesser caliper, different guns. And I see it kind of relatively the same way, though ideally I'd like to have an arrow that at least will get me cover for most of the game here in North America. But yeah, I just want to walk people through the process on how I built what the Mr. Ranch Fairy calls the adult arrow. And but before we get to that, I want to share with you kind of the studies that have been done in the past and give credit to who deserves the credit. All these studies come from a gentleman called Dr. Ashby. And you can look at his bio and all of his graphs and research and all his 12 factors for penetration enhancement. He gathered all that data and did all that work in Africa. And actually, you can go to the grizzlystick.com page, and there's a link there that will take you to the Ashby reports, and then you can have access to most of this stuff that we're talking about today. So before we get started into actually walking you through the process and how I built my high FOC adult heavy arrow, I want to talk to you about the 12 factors that Dr. Ashby talks about. So and I got a cheat sheet here so I can walk through each one of them. And he has stated these factors in order of importance. So number one for him is structural integrity of the arrow. One of the things he mentions is in his report is a tiny bit of a bend in your tip can cause an average of give or take 14% of penetration reduction on the data that he has seen. So to him, in general, the integrity of your arrow structure needs to be solid and firm. That's one of the reasons I believe they shy away from mechanicals. Kind of one of the things that we talk about in the show as well, in our podcast. So I can talk to you about the broadhead that I bought later on once I get to the arrow build. But I went with an arrow that had no screws, totally fixed broadhead. Everything is fixed, no moving parts, solid nock, good fletching, good solid structural integrity. So this is number one and most important is what's the integrity of the arrow, because once it impacts that animal, it needs to do its job. And if it doesn't have a solid structural integrity, it's not going to go through. Number two, arrow flight. So this is second most important because the arrow flight is an enabler, meaning if the flight of the arrow is good, it's going to be able to deliver the momentum that this arrow is carrying with it. And if the structure is good, then the way that arrow lands on that animal is going to allow that to give you better penetration. So you have to make sure your arrows are flying true. And I can tell you, when we walk through the process on how I built it, it's not, if this is something that you really want to fine tune and you really want to take care of each one of your arrows, you're going to have to spend a lot of time in a single shaft in just building one arrow, north of an hour on each. Look, I enjoy the process. I find it worth it. It's something that I'm passionate about. Some people don't have the time, and some people rather kind of find a system that works good for them, and they just want to keep it simple, and they get them off the shelf and they work that way. But again, nothing wrong with that at all. I'm just walking you through what I have done. So again, arrow flight is extremely important, and you have to make sure your arrows are flying true. That's number 2. Number 3 is FOC. So FOC, it's forward of center, and it has to do with the balance point of where the arrow is. So a perfectly balanced arrow, you will find the exact middle of that arrow and be able to balance it like that, okay? Then you have actual, what they call extreme FOC. Okay, extreme FOC is 19 to 30% forward of center. So, and let me take a quick step back. FOC is measured, it's measuring the length of your arrow, and then the distance from the nocking point to where the balance point of your arrow is. And then there's a little formula that you input those two distances, and it will actually give you what your FOC is. A percentage number. It's basically saying percentage-wise on the length of the arrow, where is that weight being balanced. There are different tools online that you can go and look up to, and you put those two lengths, and then you can get your FOC for your arrows. It's easy to do. If you're like me, you can find the formula and then put it in Excel, and then have your own tool built for it. Super simple. They consider extreme FOC when it takes your arrow from 19% to 30% FOC. And then there is ultra extreme FOC, which is over 30% FOC. What they're talking about with regards to FOC is that right at 19% FOC, from that point forward, the penetration gain begins. Meaning, you may have okay penetration up until 18% or so, but once you get to 19% and more, the more FOC, the more penetration gain that you will get. But please keep in mind that because of the way the formula of FOC is, the longer shafts, the longer draw length that you have, the longer arrows that you have, finding higher FOC becomes harder, because you need to put a lot more weight on your front tip to compensate for the weight of the shaft. This is actually creating a weight and a momentum that it's, combating the forward weight of this arrow. So the longer your shaft, the harder it is to get better FOC, because you got to put higher weight on the front. So it's a balance, and you have to kind of find out what works best for you. In this particular, and I'll walk you through, in this particular shaft, I was able to achieve a 22% FOC, which I'm extremely happy with for the arrow length that I use. Number 4, mechanical advantage. So the angle of incidence and the number of blades are good examples of what a broadhead mechanical advantage may be. And so the steeper, if you think about this, if you look at this broadhead, the steeper the angle, the more incidence is going to have and into the animal. It'll be easier for it to penetrate. If you have something here that is more blunt, okay, flatter on top like that, it's going to be harder for it to penetrate because of the shape and of the broadhead. Also, the number of blades. if you have, this is a 2-blade, but if you have a 4-blade, now you got, you know, an intricate number of blades trying to cut through issues, and it's reducing the mechanical advantage of penetration that a blade may have. And that's the reason why I decided to try a fixed 2-blade broadhead for this setup. But again, it doesn't necessarily mean that the 3-blade or the 4-blade are bad broadheads. It's just differences in what advantages you can gain on penetration. But again, your setup may be good enough or great in penetration already that this may not make a huge difference. Thus, the reason why it's actually at number 4. Number 5 is actually shaft diameter. So, and this is pretty interesting because they show in their data that 10% penetration gain is gained when your shaft diameter is at least 5% smaller than your broadhead ferrule diameter. Okay, so I went ahead and measured, and these arrows that I actually use for my setup, these are the series of polos, and they come in with these inserts that are slightly tapered, and they get a little wider at the tip, closer to the ferrule of the broadhead. So when I measure the ferrule of the broadhead and I measure the OD of the outside diameter of this shaft, I have more than 5% difference, meaning my shaft is smaller. What's the thought process behind it is that, okay, the broadhead has gone through, there is no more additional restriction. The big punch hole has already been made. All this stuff is just following behind without adding additional friction or restrictions or bigger diameters that they have to continue to open up what the arrow actually is going through. That's anyway the way I interpret it. Then number 6 is arrow mass. So this is very interesting because it changed the way I looked at, you know, kinetic energy and momentum. In the past, I used to concentrate a lot on kinetic energy. You know, I was like, yeah, you know, I want bigger kinetic energy. And kinetic energy has a lot to do with the speed. And, you know, us bow hunters were all into, oh yeah, you know, we want more speed, and, you know, we want that arrow to fly quick, especially whitetail hunters, which it is true. It is important. Whitetail is an animal that reacts to sounds extremely fast, and they can dodge these arrows in no time, you know, depending on the distance of what you're shooting them and how, you know, quickly they can hear you. So yeah, speed is important, but when we're talking about penetration, it is extremely important to look at momentum. And momentum is directly related to the weight, the total weight and total mass of your arrow. The more mass, the more momentum. And the more momentum, the more penetration gain you're going to get. Kinetic energy is not a predictor of outcome tissue penetration. So when you think about penetration, you shouldn't be thinking about kinetic energy because they're not physically related. So number 7 is actually blade edge finish. Okay, so they show 26% advantage over non-sharp edges and 60% advantage over serrated edges. That's the reason why, again, I picked this broadhead, because it has non-serrated edges, and this is a broadhead that is a single bevel. It's simple to sharpen, and it is extremely sharp. So it is very important to take the time to actually make sure that your blades are sharp. You owe it to yourself as a hunter. You owe it to the animal as an ethical hunter, because it will have an impact on penetration and tissue tear. I did get this tools. These are the Stay Sharps. You can look them up online, and basically what you do is you actually put these guys on your broadheads. You tie them up and they stay at an angle. They have them from different type of broadheads, and what you do is you get different size grits, like I have here. You get different size grits, and then you start from the coarser to the finest, and you just kind of go back and forth. They got videos on how you're supposed to do this, and when it gets to the very end, they get very polished. And then the last thing that I learned from the Ranch Fairy is this guy right here. So I believe they call this the strap. And what you do is you actually put some compound on the coarse side, and then you simply just slide it like that in the direction of the edge, you know, not against the edge, but just kind of away from it. And then you do that on both sides, and then you turn it around, and you actually keep doing, you know, do that on the soft side of this leather. And this is a game changer to me. I've never had or seen a blade so sharp in my life until I started using this methodology. So again, it is super important to make sure that your broadheads are extremely sharp, and be careful sharpening them, because you can get cut easily. So shaft profile. So when they talk about shaft profile, which is actually factor number 8, is your shaft completely parallel, meaning has the same diameter from top to bottom, or is it tapered? You know, and I think this applies a bit more to wooden arrows. So basically what they're saying is kind of the same principle as your ferrule being bigger than your shaft. Well, if you got a taper shaft, it's better for it to be thicker, or a bigger OD closer to the point, and then smaller OD as it travels back to the end of your arrow. What they're saying is that there is tapered shafts actually have an 8% advantage in penetration over parallel shafts. Again, I believe there are carbon taper shafts in the market, but I just went with a regular taper shaft. I didn't think that was going to be a deal breaker for me on building my arrow. And I also want a shaft that you know, is accessible in the market and not so hard to find and not too expensive either. Number 9 is Broadhead Silhouette. So the broadhead finish in general, it's important, and what that means is, like, how complex is it? You know, how smooth is the transition from the blades into the ferrule, and actually from the ferrule to your insert, and that applies from your insert back to your shaft. You know, are those transitions smooth enough to where that arrow doesn't have to work through a lot of those variances as it travels through mass inside the animal? So the silhouette in general of the broadhead is also important. You don't want something that is way too complex. It's got a lot of sides to it, and that, again, it's not saying that it's not going to have good penetration. It's saying that the percentage of penetration may be reduced because of the additional work of that having to go through the animal. And then number 10 is the type of edge bevel. So one of the things they are saying is that single bevel broadheads consistently cause a high frequency of massive bone splits. No downside on single bevels, and make sure you fletch accordingly. So they don't see any downside on single bevels. That's the reason why I picked a single bevel broadhead. With the with regards to fletching single bevels, you have to make sure that you know, is it your right bevel or left single bevel. In this case, it's actually easy to do. What you do is you look at your arrow like this, and then my edge, actually my sharp edge, I can see the sharp edge on this side is the bevel is on the left hand side basically. So if I turn it again, my bevel is on the left hand side. So this is a left bevel broadhead. And the reason why I picked a left bevel broadhead is because when I was going through my process and shaft tuning, I noticed that my shafts naturally want to come out, even with field points and no fletchings, they want to come out and they start turning to the left on their own, coming out of my bow. So my bow, as it shoots the shafts, they have a natural left spin. Thus the reason why I wanted a left bevel, and thus the reason why I ended up giving my fletches slightly to the left with a 3-degree helical to the left. So make sure that those things match. Because what happens is if you have a left bevel and then you fletch to the right, may not be an issue, but they're kind of acting against each other, and it could potentially, give you some flight issues. May not. Sometimes what would happen is that maybe the broadhead is more dominant, and then as it comes out, it kind of wants to, the fletchings want to correct it, and then it may turn the other way around. Or maybe I'm wrong. Maybe the fletchings are more dominant, and the broadhead wants to turn left, and then because of the fletchings, it just in midair, it will kind of maybe make the arrow plane a little bit, and give it a complete opposite rotation. So you want to make sure that those things are synced up. Again, that makes number 2, it matches with the importance of number 2, which is your arrow flight. And then number 11 is the tip design. So long short, they went through the process of testing all the different tips on the broadheads, and then they found out that the Tanto tip is 110%. It can improve your penetration by 110% compared to the worst tip that they tested, which is the concave tip. So when I'm talking about Tanto tip, let's see if you guys can see this. A Tanto tip is basically that small wider angle triangle at the tip of the blade, at the tip of the broadhead. So you got a wider angle and then the very steep angle coming out. So that little triangle at the top like that, that's what's called the Tanto tip. And then number 12 is arrow mass above heavy bone threshold. So what they found out is that arrows weighing around, from 650 and above, right around 650 grains, showed that that's the threshold for actual bone breaking. Again, I've shot my arrows in the past weigh 495. That's not too far. I mean, it's 150 grain shy of that threshold, and I have broken bone with 495 grain arrows. But what they're saying is, right at 650, they see probably more consistency at breaking bone, especially large bones and large splits in bones. And I'm going to show you right now a pig that I killed with this arrow setup, and I shot it on the shoulder blade. It actually skipped the first shoulder blade, went through the body, and then on the way out, it shattered. It went right through the opposite shoulder blade, and I'm going to show you the split that it caused. what you want is you want a true flying arrow that it's got great structural integrity, excuse me. And then you want to spend the time to make sure that your arrow is tuned in and it's flying properly and it's balanced, and you want to know what your FOC is, and you want to make sure your broadheads are sharp, and you take all these things into consideration. One of the things that Ranch Fairy says is like, hey, a lot of people is concerned about, you know, how the arrow gets to the animal, but you know, some people are not taking into consideration, okay, once it gets to the animal, what the arrow needs to do is extremely important. And you know, as we call it, actually, I happen to do that shirt, we want 2 holes. So that's ultimately the goal, is you want to achieve 2 holes, you want to have solid pass-through penetration, and that's going to be the most ethical shot and improve your recovery of your animals. Arrow flight is so important, and I'm going to talk about it when I go through the process, because when that arrow, if I shoot at a target and this arrow is coming perfectly straight and it hits that target completely perpendicular, all that weight of that arrow, all those, in this case, 710 grains of mass that are coming at a very high speed, in my case 243 feet per second, it's all getting concentrated on that little tip, and everything's pushing straight from behind, so there's no inefficiencies as far as when that's hitting that target, all that weight is being concentrated at that one point and is going to continue to push through that one point. If you have bad arrow flight, what's going to happen is that if that arrow, say, is coming like that and it hits the target like this, so look immediately what happens. My hand just kind of kicks that tail on this side. So now you have an angle of incidence that part of your force is going in this axis and the other part of your force is going in this axis. So you're hindering, by the angle of incidence, you're already hindering the power that this arrow has. If you're at, say, I don't know, I'll venture out to say if you're at a 45-degree angle, by the time you hit, you may lose 50% of that arrow penetration capabilities. So that's why you want to make sure your arrows are flying perfectly straight. That being said, you know, Dr. Ed Ashby has all these, you know, research listed there, and I know that Mr. Troy, the Ranch Fairy, has a YouTube channel which I highly recommend you guys to go and watch, because all this process I started on building my arrows was because of, you know, all the videos, the YouTube videos that I saw of him explaining all of this stuff. And he makes great sense in a lot of the stuff, and that's the reason why I wanted to kind of try something different. You know, what I'm going to do today is I'm going to summarize all the videos that he showed and try to summarize it and condense it into just this one video of explaining how I went through the process and the steps I took to go through this process. So let's go ahead and actually get started. So the first thing you want to do, and again, Mr. Ranch Fairy says this, is that you want to make sure that your bow is perfectly tuned. Okay? There's no point in you starting all this process when your bow is not perfectly tuned, because then you're just not making any progress. You're going to be chasing your tail, and it's going to be terrible for you. I mean, you're going to be super frustrated trying to do this. So, look, make sure that, and there's tons of videos on bow tuning that I highly recommend. But if that's something you don't want to get into, make sure you take it to a good pro shop. and make sure they bow tune, that they tune that bow for you the best possible. And by that I mean you want to make sure that your sight is level with, you know, with your riser and your strings, and then also want to make sure that your release is actually level, and then that your cams are synced. Okay, so I mean there's a ton of other stuff that you can look at, but you know, primarily you want to make sure that your bow is shooting as per specs. Okay, once you have that and you're comfortable about your bow shooting properly, what you're gonna do now is look at you got to start with your shafts. Okay, what shafts do you want to use? So think of your poundage first. In my case, I used to shoot 70 pounds. Now I crank this one up to 76 pounds. Okay, so depending on the poundage and depending on what shafts do you want, I recommend you go into the webpage of the shafts that are selling the shafts and look at the different scales that they have. They have tables that, based on your draw length, on your poundage, you know, they recommend a specific spine. Okay, sometimes you kind of get in the middle between the two. In my case, I went to the Sirius site and looked them up, and they have a kit that they call it the Ranch Fairy kit. And basically what they do is they give you 2 shafts, so a total of 4, but 2 of each spine, and then they give you different weight field points. So what is the objective? The objective is that once you pick your shafts, the ones you want to have and marry with, because you want to make sure that you do this with the shaft that your arrow is going to be built with, not any other shafts, and then change them along the way because they're going to be different. I picked up the Apollo shafts, and because of my draw weight, I kind of went with the 250 and the 300 spine. Looking back, I probably could have gone with a 200 spine as well and try that. But I did get the 200 spine and the 300 spine, and they came with different field points. Okay, so the shafts come in with an 100 grain insert. Okay, so I glued the 100 grain insert into my shafts, and then I go and started testing every field point at different grains through paper. So again, first things first, one of the things they once I glued that insert into the shaft, I went through paper and I screwed in an 100 grain insert. Please keep in mind when you're doing this, you don't do this with your broadhead. Okay, I made that fatal mistake. You don't do that because at this point you don't have your fletchings on. You do want to make sure that you do have the Nock that you want to be using. So you take your bare shaft, you put the Nock that you want to be using on that shaft, and then you put your insert there and you glue it in there. And now you're ready to go and start shooting through paper. I shot with a 100 grain field point, a 200 grain field point, a 225, 250, 275, and 300 grain field point. And I did that with my 250 spine arrow and with my 300 spine arrow. Okay, and I'm going to show you the results. Again, this is just bare shaft shooting. You don't have fletchings. You do have the Nock that you want to use. Do not shoot with broadheads. So check this out. All right, so as you can see now, this is how my shots looked. So with my 250 spine, this is the tear I was getting through paper. And I'm shooting these right at 21 feet, which is what they think is the moment in which that arrow paradox stops, you know, bending and it gets straight. So you shoot through paper right at 20, 21, 22 feet. And what you're looking for here is just a reference. Okay, you're not looking for exact at this point. You're just looking for a reference. You're looking for improvement. So 100 grain, 200 grain, 225, 250, 275, 300. Okay. Then I shot the 300 spine, 100, 200, 225, 250, 275, 300. I actually sent this picture to Mr. Troy, the ranch fairy, and his recommendation was like, look, it looks like the 250s are working best for you. I would recommend, because of the general behavior, to go with the 250 spine. And he also said you may want to adjust your rest a little bit, 1/16 to the right and 1/16 up. And when I did that, I got this right here at 20 something feet. And then I started tinkering with it a little bit more, and I went back to 20 yards, and I'm getting these bullet holes right here. So that for me was extremely telling, and it supports what he says is like your arrow shafts should fly true without fletchings. Fletchings are there to help you, to aid the flight, and to help you, you know, minimize the mistakes that you may have as a human or anything else that may come along the way. You do want the fletchings in there, but your arrow should fly true without it. Now I know that, okay, I want to be using the 250 spine shaft from the Apollo 250 spine shaft. And I know that my insert is 100 grains. And I know that the best field point that worked better with my setup was the 250 grain field point. So what that's telling me is that I have 250 plus 100 grains insert. That's 350 grain of weight on my tip, on the tip of my arrow. Okay, so 350 is what I need in the front of my arrow. So at this point I say, okay, well, what broadhead do I want to use that meets most of these 12 factors? And I started looking at different broadheads, and look, at 200 grain broadhead, a set of 3, they become expensive in the different places that you look them up. There's a ton of great broadheads out there. The ones I ended up with, it's actually a smaller company. It's called Bowmar Broadheads. And the way you spell that is Abowyer. You can look them up online. There are 200 grains. Okay, so I'm like, I need 350 grains on the tip. I'm getting the Bowmar 200 grains. I'm missing 150 grains. So how do I compensate for that? What they do at Serious Archery is they actually give you an option. They send you pretty big inserts. And I'm going to try to see if I can find one of them. Yes, here they are. Their inserts are like 200 grains, okay? And what you do is you then cut your insert, and they give you sections showing you the 25 grain cuts. So I cut these to be 150 grains. So now my inserts are 150 grains, and my broadhead is 200 grains. So I got a 350 grain weight in my tip, the tip of my broadhead. So that is how I ended up, you know, landed on my design. And as far as fletchings, you know, again, Mr. Troy said, you know, just really any fletchings, the blazers are fine. These are the Q2 eyes. and I kind of like the shape they have, and I like the profile that they have at the bottom. It feels like they actually can hold the glue a little better at the bottom. Quick tip on the glue. I've looked at a lot of different glues, and I've never had much luck with glues and fletchings, and this one seems to be doing the job so far. This is the Loctite Super Glue Gel Control. It's got a nice dispenser. You press on the sides and it goes back in. You kind of clean the tip after you do that. You put it back on, you keep it in the refrigerator. It does an excellent job in keeping the veins well glued. So now I knew how my setup was supposed to be, but now I can actually walk you through real quick through the final arrows and the process that I did for each one of my arrows after knowing how I wanted to set it up. So the first thing you do when you get a brand new shaft, obviously you get it cut to the right length, okay? And in order to avoid confusion, make sure you learn and you know exactly what your, carbon to carbon length is. Keep in mind that before you decide on changing your carbon to carbon length, make sure you know which nock you're using, and actually test it on your bow, because when you are on a full draw on that bow, you want to make sure that you also keep in mind the profile of your insert and the profile of your broadhead. The last thing you want to do is have an arrow that is too short for you. By the time you draw, you can cut your finger because it's, your finger may be close to the bottom of that riser or the grip there, and you can cut it. So make sure you leave yourself enough clearance. You need to understand the length of your nock, length of your insert when it's fully in place, and then the length and the dimensions of your broadhead. So make sure you keep that in mind before you come up with your shaft length. Then we go into the process of actually building your perfectly arrows, OCD arrows, as some people may call them. There are a ton of videos online of people going through this process, and they all have really good information. So some of them are extremely good, and one of them I really like is by Bowmar Bowhunting, and his name is Josh. And the guy is extremely technical and very knowledgeable of how to build arrows. So I did learn a bunch of stuff from him as well. So the first thing I like to do is once they're cut, if you get them from factory, if you don't cut them yourself, you want to make sure that the edges of the ends of your arrows are completely flat and perfectly straight. Because, believe it or not, when you have your nocks in place, if that nock is not completely flush with that surface of your shaft, it may have an influence on how that shaft is coming out of your arrow. It may put more pressure on one side of the shaft than the other, thus generating arrow flight issues. Okay, the same thing with your inserts sitting flushed against the shaft. It may have an impact on how flush they are and the arrow flight and the way the weight gets distributed once it hits on impact. So the tool I found most useful to square the edges of my arrows is this fast tool. It's by Nock, and it comes with a little circled sandpaper that you put here at the end, but it kind of wears out eventually. So best thing I found is I went online, I bought anti-slip tape used for skating, and it comes in a roll, and I just kind of cut pieces to it, and I can replace them over and over. But the way it works is simple. It has this little profile, and what you do is you set it up here, and then you just basically spin your shaft like that, and make sure that it squares the end of your shaft properly. And you'll see there's some material of carbon being shaved off. Now, the best thing you can do to actually make sure that you're getting, you know, full contact is you take a silver Sharpie or something like that, mark the edge of it, and then when you spin it here, you make sure that all that Sharpie that you put on that edge is gone. Then you do the same thing on the other side. One thing I'll also recommend at this point to do is you can get one of these, and these little stones usually come in with a set of 12 on my old Easton full metal jackets, and I'm sure some pro shops may have tons of these available for you to, you know, get from them. And what you do with this is actually tapers the inside of the carbon shaft, and you want to do this on the Nock end, and the reason being is because in my case I like to use the nocturnal Nocks, and the nocturnal Nocks you have a little bit of a profile. Sometimes that profile is not perfectly flush. Actually having that little bit of taper where you actually put this little stone in there and shave off the inside of that carbon shaft, it gives it a much better profile for that Nock. Once you have taken care of both ends, the next thing I recommend to do is get you some acetone and Q-tips, and make sure that you clean not only your shaft but also the edges of the places where you just kind of trimmed your edges, and the inside of the shaft for any residues. That way your shaft is completely clean. Your acetone will really help to get everything clean. You can use some rags to clean your shafts, and with some acetone in them. Now, be careful. If you really like your designs on your arrows, that acetone will also erase some of that stuff. So if you are planning on keeping those, make sure you don't run your acetone through that. The next step of what you want to do is you want to take your insert. So in my process, I already defined that my insert needed to be 150 grains, okay? Because I want 200 grain broadhead. So now what you want to do is you want to spin test your shaft with that insert. When you put that insert in there, you make sure it sits flush with the edges that you just trimmed, okay? And also, you make sure that you put a mark between the insert and the shaft. What you do at this point is you actually take your broadhead, okay, and you put your broadhead in there. You don't glue the insert yet, but what you're doing is you're simply spinning that shaft on your spinner with that broadhead in there, and watching to see if that broadhead is actually spinning true and perfectly straight. If it's not, what you do is you slightly move your insert with your broadhead, and then you try it again until you find that one spot where your shaft, your insert, and your broadhead are all spinning perfectly straight. When you find that spot, you make sure you mark that one again, and make sure you know which mark that is, and then that's the place where you want to glue in your insert. So you take your broadhead out, and then you glue in your insert. Your insert is already in place, already glued. You put in the Nock that you're going to be using for that arrow, and then what you're going to do is take a field point weight from the kit that you got that matches your final setup. So again, when I shot through paper, the field point that I needed, that worked good for me, was the 250 grain, but my insert was 100 grain, so 350 total. Because I want a 200 grain field broadhead, I went with a 150 grain insert. Thus, when I shoot this puppy through paper, I need a 200 grain field point to match my future 200 grain broadhead. So with a 200 grain field point and the 150 grain insert, now I got my 350 grain arrow. Glued insert, 200 grain field point, and just the nock. And at this point, I go out there and I make sure I got 22 feet from me and the paper, and I got enough space behind the paper to a solid, to a good target for field points. And then I start shooting my arrow. And what I'm going to do at that point is I'm actually going to mark, as you can see it here, I'm going to mark that shaft with the nock of on my initial mark, and I'm going to start the nock tuning process. So I'm going to shoot, and I'm going to see how it's actually tearing my paper, and then I'm going to make tiny adjustments. I go clockwise just a hair and shoot again, and keep doing that until I actually find a spot where that nock aligns with the index of that arrow and actually shoots very close to a bullet hole, or if not a perfect bullet hole. When I find that spot on that nock, then I mark it and make sure that that's a permanent mark for me. And look, if your nock is slightly loose with regards to your shaft, I recommend putting a dot of glue so it doesn't move point forward, if you're okay marrying that nock to that shaft. So the nock tuning process may take you 2 shots, it may take you 30 shots, and it just depends on how lucky you are in landing that nock in the correct place. After you nock tune, then a good thing to do at that point is actually, when you shoot, is make a little mark where that, where that nock mark is, and now shoot 5 feet apart from that target, and then see the rotation, which way is that shaft turning coming out of your bow. In my case, when I shot, that mark was slightly to the left, so I knew that my arrows bare shafted like this with the field point were actually coming out and making a slight turn to the left when landing on the target. So I knew that left was the tendency of my arrows. That's one thing that is actually good to know. After you do that, what you're gonna do at this point is, okay, you got your insert, tune, spin tested with your shaft and is already glued in place. You got your nock tuned and marked with your shaft. You know which direction your shaft is spinning coming out of your bow. And now the next step is simply to put your fletchings on. And again, in my case, I ended up using left 3-degree helical to match the broadhead that I chose, my 200 grain for my setup. So the tool I use, and look, this is kind of on the high end. There's tons of really good jigs out there, but I really like this one because it gives me a lot of options on right and left helical. Don't have to be buying different clamps, and I can do fletch pretty much anything with this tool. This is the Last Chance Archery, the Bane Master Pro, and again, it's got a lot of micro adjustments, and I just really like it. The material in which these 2 rods are made it's great because any glue that gets left on here, you can simply just run your finger through and it scrapes it all out, and it's just back to being completely smooth. So I've tried a few different ones. Definitely my favorite, and as much as I fletch, it was worth for me the investment. So you fletch your arrows, and then once you get them fletched, again, minimal glue. I told you what glue I use. I can do more detail videos on this in the future if y'all want, but as of now, I'm just sticking to the process of building my adult arrow. Okay, so once your arrow is finalized, you know, in my case, I pretty much met most of the 12 factors, which was my ultimate goal anyway. So my total arrow weight, and I use one of these grain scales, ended up being exactly 708.8 grains on this one arrow specifically. So you got your vanes, you got your insert, and you got your broadheads, and then you got your Nocks. And then at this point, you take your safety precautions and go out there and start, you know, testing your setup at different distances. At this point, you really have to go out there and start readjusting your sight. So here's another tip. With my 495 grain arrow, I used to shoot a sight, the Trophy Ridge React, which I loved because I used to sight in 2 pins, and man, it just all the other pins will just kind of fall into place, and it would be extremely accurate for my setup. And I like that because I don't have to take too many shots to make sure that my pins where they needed to be. One of the things I found out with my heavy arrow is that now it doesn't matter how much I expanded those pins, I ran out of room because obviously I got way more drop in my arrow. Heavier arrow, less speed, bigger drop at distance. So I ended up pulling one of my old sights that I had in there that I can adjust the pins manually, and I have been able to adjust it so far to 40 yards, but planning on doing 50 and 60 and so on and so forth. So just keep that in mind too. All those adjustable automatic Trophy Ridge with very heavy arrows, that the algorithm on the way those are built may not work. It did work for me if I went, instead of 20, 30, 40, 50, 60 yards, if I went 20, 25, 30, 35, 40 yards. But I didn't want that because then my pins were then at that point too close, and it was distracting for when I was trying to get my target in place. So yes, the idea when you build your arrows, and you're very meticulous about building them also, is to make sure that every arrow is within 2 or 3 grains of total weight difference between one and the other. And again, Mr. Josh with Bowmar Bowhunting goes through a very good process of showing you how to weight each individual component, your broadhead, your inserts, your Nocks, and even your vanes, and separate them into heavy, medium, and light, and then, you know, mix and match them to actually make sure that your arrows are all about the same way. So you take the heavy, say the heavier shaft or the heavier broadhead with the lighter Nock, and so on and so forth. So that being said, I just want to walk you through the results of what I've found in performance between these my old arrows which is the ones that you've seen me use when elk hunting. So this is a 5mm full metal jacket. I use the 3-blade cut-on contact Reckoning from Bloodsport, and then the Nock and the Blazer vanes. And this arrow weighs 495 grain, and this arrow weighs 709 grain. Okay, this arrow was giving me a velocity of about 267 feet per second. Okay, at 70 pounds, 29-inch draw length. This one was giving me a velocity of about 230 feet per second at 70 pounds with a 29-inch draw length. Now, my kinetic energy stayed about the same. Again, we don't worry about kinetic energy, but my kinetic energy stayed about the same. I had a weight increase of about 30%, but I also had an increase in momentum by about, the same percentage. So bigger mass, more momentum, slightly less kinetic energy, less speed. What I did taking from this arrow to this arrow was sacrifice speed and gain momentum by adding mass. That's exactly what I've done in these two setups. On top of that, after I finalize that, and I don't recommend this because it may mess with your setup and you may have to go through the whole process again. But what I did, I actually increased the poundage on my bow to 76 pounds. So now what I have done is with more poundage on my bow, again, don't care about the kinetic energy, but my speed went up. So my speed went up to 243 feet per second, and thus my kinetic energy is now like a 95 foot-pounds of, kinetic energy. But my momentum went up even more. So my momentum is right now sitting at 0.77 slugs, which is a mule kick, okay? So final words. This arrow setup is great, and it worked great for me for shooting whitetail deer. It was fast. Yeah, I always got, 2 holes, and it got the job done for me. But I could tell there's a couple events in which I shot whitetail and it hit bone and deflected the arrow. Still got the job done, but I could see arrow deflection. When I talk about hog hunting, my favorite hunting, and elk hunting, I have no doubt this setup is going to be more lethal and is going to help me guarantee 2 holes. I've only shot 2 animals with this setup so far. The first one was a hog. She was a medium-sized hog. Again, I missed the first shoulder blade, went through the entire body, and shattered the second shoulder blade. I did not hit the spine on that pig. I, again, went through the shoulder, and that pig did not move an inch. It dropped on the spot. That was kind of surprising and impressive to me. Pigs are tough. And then I shot a whitetail deer at 20 yards. Yes, very close distance. Again, 243 feet. That's plenty fast, but this arrow went through that whitetail like butter, and that whitetail didn't run 25 yards from where I hit him, and it was dead in seconds. So yeah, shot placement has a ton to do with this, but also having the right arrow for the right setup is going to help. I'm not saying this is the right way to go. I'm saying this research has proven, and the jury's still out for me. I still got a lot more tests to do. I want to shoot big hogs. through the shoulders and see what happens, you know, and just try to make the best shots on the hogs as possible with these things and see what happens. Jury's still out, but you know, so far these factors have proven that your penetration can be improved if you follow some of these indications to improve your arrow setup. Look, man, like I said, it's fun. I have a blast just kind of testing these things and working them out and trying them out. And you just got to try. Like Mr. Troy would say, just try. You're going to learn through the process, and it's going to enhance those knowledges and those skill sets, and you know, you're going to be more and more aware of all these things. I love my arrow setup now. Of all the factors, I can still tell you that I'm extremely happy with structural integrity of this arrow. There's no screws on my broadhead. Everything's nice, tight and snug, and there's no moving parts. Arrow flight, if you're going to test your setup after it's done and ready with your broadhead, one of the things that a recommendation from the people at Serious Archery was that use lipstick, women lipstick, and just put it on the edges of your fletchings here. That way when you shoot through paper, you can actually see the color of which tears are actually from the fletchings, and the ones that don't have color is your broadhead. That usually helps you, you know, if you want to shoot through paper after you have your broadhead in place. That's your arrow flight. You want to make sure it's flying really good. Your FOC, mine ended up being 22%. It's right here. You can see how far forward that is compared to the center of the arrow. My old arrow had 7% FOC. It was almost balanced. Okay, as you can see, it's kind of somewhere in here. And look at the difference. So I moved that weight, that balance point about that much, about 2.5 inches or so forward. Okay. Mechanical advantage, the angle of incidence. That's why I went with this broadhead. It's got a very steep angle of incidence, and it's got good transitions to the ferrule and into the shafts. Shaft diameter. This shaft is smaller than the bottom of the ferrule, and the inserts are tapered a little bit to where it actually meets that. Arrow mass. Again, this arrow has a heavy mass. It's a heavy arrow, maybe a little too heavy, you know, but it depends of what you want to shoot with it and what you're comfortable with. Look, I know that I'm not going to want to shoot a whitetail deer with this arrow at 240 feet per second farther than 35 yards. I mean, I just know that those deer have the ability to react way too fast, and that's a shot that I would even question with this old setup of mine. So you just gotta understand your limitations. You gotta understand your flight path and your arrow speed to make those decisions. Blade edge finish. I told you how I sharp the blades, and I'm proud to say now that I'm capable of making them surgically sharp. Shaft profile. That's the only one that I didn't meet. I don't have a tapered profile, but again, not a big deal for me. I wanted something a bit more accessible and simpler, and so that's why I went with a parallel shaft. Broadhead silhouette. I already talked about the transitions and the shape of the broadhead, and then the type of edge. And this is a single edge. That's step 9, single bevel edge, and that's what I went with. And then the tip. The tip is the tanto tip. which again, that's why I picked up this broadhead. And then arrow mass that gets to heavy bone threshold, they're talking about getting close to 650 grain. Excuse me. This one is 710, way above that, but it doesn't necessarily have to be that heavy. That just happened to be the setup that after I went through the process, it just ended yielding that way. So that's all I have with regards to the process I went through, and more than glad to take all the questions and comments and that you may have, and hope this video was helpful. So thank you.